Everyone, I'm Dr. Anjana Adhyapak. I'm an associate professor in the Department of Pharmaceutical Quality Assurance, Kelly College of Pharmacy, Belgavi. And today, my topic of presentation is going to be on drying. The contents of my presentation is going to be definition, significance of drying, mechanisms of drying, classifications of dryers, and I'm going to explain on the tray dryer, drum dryer, and the spray dryer. So, what is drying? Drying is defined as the removal of small amounts of water or other liquid from a material by the application of heat. It also includes the removal of volatile liquids or water from another liquid or a gas or a suspension. So drying again can be with heat or without heat. I'm coming to it in the next. So it can be non-thermal drying or it could be thermal drying. So non-thermal is when you're not going to apply heat and thermal is when you're going to apply heat. So non-thermal example expression, like you're going to remove water out of sponge, one of it. Extraction, that is when you're going to extract the liquid from a solid by the use of a solvent. It could be adsorption, that is by using a desiccator where you're going to keep materials like silica gel or anhydrous calcium. Then it is absorption, that is the absorption of the moisture from the gases by the passage of sulfuric acid, and desiccation, that is keeping it in desiccators for a time. And thermal drying is going to be using various drying equipment in which it is going to be by the application of heat. And in heat, it could be either by conduction, convection, or convection. What is the significance of drying? Now, drying is the terminal process in most of the pharmaceutical procedures that we are going to take. And hence, drying is a very critical component or an unit operation when you're going to be talking about. So during preparation of bulk drugs, for example, dried aluminum hydroxide or spray dried lactose and powdered extracts are done by drying. Presentation, that is preservation of the drug product. So most of the time moisture is going to lead to degradation or oxidation of certain materials which are moisture sensitive. So for those, it is important that you're going to be drying. Therefore, drying is necessary, especially for crude drugs or an animal and vegetable origin. Then blood products, skin and tissue which undergo microbial decomposition. Third is improved characteristics. That is, drying produces materials of spherical shape, uniform size, and free flowing and enhanced solubility. All these properties are necessary when you're going in for compression of tablets or filling out of capsules or for solubility criteria. Therefore, drying again becomes very significant. Coming to the classification of dryers. The classification of dryers is based on whether it is a static bed dryer. That is, there is no movement of the material or the equipment. So those are called as static bed dryer. An example for static dryer is a tray dryer or a freeze dryer. Then you have moving bed dryers, wherein the system in which the drying takes place and there is a partial movement or separation or partial movement so that they flow over each other. Example is a drum dryer. And then you have fluidized bed dryer. That is a system in which there is the solid particles are partially suspended in hot air. And the last one is the pneumatic dryer, in which the system in which the drying particles are entering and they are conveyed at a high velocity of gas stream. An example for this is a spray dryer. Now let's talk about the first one, that is the tray dryer. So as you can see, it is nothing but a tray that is going to be put into a dryer. So these are also called as tray dryers. And the principle here is that hot air is continuously circulated and forced convection takes place to remove moisture from the solids that are placed in the trays. Simultaneously, the moist air is removed partially, and this is also called as shelf, cabinet, or compartment dryer. The construction is that it consists of either rectangular or square chambers, and trays are placed inside the heating chamber. As you can see here, there are multiple trays. You can see the material that is being dried. So the laboratory tray dryers contain around 3 trays minimum, and industry they contain around 20 trays. Each tray is either rectangular or square, and it is about 1.2 to 2.4 square meters in area, and these are usually 10 to 100 millimeters deep. The trays are 10 to 100 millimeters deep. The distance between the bottom tray and the surface of the substance loaded in the subsequent tray must be 40 millimeters so that there is sufficient place for the air to pass over the trays. This is how it is schematically it can be done. These are the trays. These are the heaters that are placed. There is an air inlet. Sorry. This is the air inlet, and there the air is going to be let in. It is going to be going through the heater. This heated air is then going to go over the trays as it is good in this fashion. So there are vanes that are attached inside, which will allow the direction of the air to go over the trays, and it is going to be going. So at every pass of this hot air, it is going to remove some moisture. Then the moisture that is going to be trapped in the air, so the moistened air, there is an outlet which is going to be taken out. However, only around 10% of the air is let out. When 10% goes in, fresh air is going to be let in. So this is how it is going to be working. The fan is kept to regulate and to see that the air passes through uniformly. So the working, wet solid is loaded into the tray. Fresh air is introduced through the inlet, which passes through the heaters and gets heated. The air is circulated by means of around 2 to 5 meters per second. Turbulent flow lowers the partial vapor pressure in the atmosphere, and it also reduces the thickened boundary. As the water evaporates from the surface, the water diffuses from the interior of the solid by capillary action, and this occurs in a single pass. The time of contact is short, and the amount of water picked up is in a single pass is also small. Therefore, discharged into the the fresh air is discharged to the tune of 80 to 90%, circulated back through the fans. Only around 10 to 20% of fresh air is introduced. So advantage, handling of the materials can be done without losses. It can be operated batch wise for following reasons. That is, each batch can be handled as a separate entity. The equipment is readily adjusted for use of drying in a variety of materials, and valuable products can be handled efficiently. The only disadvantage is time consuming and also the labor cost, because you need excess labor to load and unload the materials. Uses, it is used to dry sticky materials, plastic substances, precipitates, chemicals, tablet granules, and powders. Coming to the next, that is the drum dryer. So this is an example for moving bed dryers. Drum dryer, as you can see in the picture, there is a drum which is going to be dipped into the solution. There is an applicator, there is a doctor's blade or the scraper, there is a belt conveyor, the product is received, and this is the feed tray. So this drum is hollow, into which you are going to be putting into which hot steam can be passed. Steam will be passed. So a heated hollow metal drum rotates on its longitudinal axis, which is partially dipped in the solution to be dried. The solution is carried as a film on the surface of the dryer, that is here. Once it dips in, there's going to be a small film that is going to be formed. So as the film is going to be formed, by the time it comes here, it gets dried. And then, sorry, it is going to be dried, which is then going to be scraped with a doctor's blade. Hollow metal is drum. Then construction, it consists of a horizontally mounted hollow steel drum of 6 to 3.6 to 3 meters diameter. These are huge equipments actually. Although the diagram is small, I will show you the industrial model soon. Whose external surface is polished. Below the drum, the feed pan is placed in such a way that the drum dips partially into the feed. On one side of the drum, a spreader is placed, and on the other side, the doctor's knife is placed to scrape the dried material. A storage bin is placed, connecting the knife to collect the material. So working, steam is passed in the drum. Drying capacity is directly proportional to the surface area of the drum. So bigger the drum, sooner the drying takes place. Heat is transferred by conduction in this method and to the material. So drum is rotated at a rate of 1 to 10 revolutions per minute. So it is a very slow revolution, so that the sample that is picked by the sample that is forming a film on the drum, by the time it comes to the other side, it should come dry. Therefore, the revolutions is really very slow. And the material is completely dried during its journey in slightly less than one rotation. The dried material is scraped by the knife and it falls into a storage bin. The time of contact with the hot metal is 6 to 15 seconds only. Therefore, it can be used for thermosensitive. Then advantages, that drying time is only few seconds, hence heat sensitive materials can be dried. Less space as compared to the spray dryer. Rate of the heat and mass transfer are high. The product obtained is completely dry and it is in the final form. The disadvantage is that the maintenance cost is high and the skilled operators are required, and it is not suitable for solutions of salts with less solubility. It is used for drying solutions, slurries, suspensions, and also drying of products like milk products, starch products, ferrous salt, suspensions, then pigments, antibiotics, malt and glandular extracts, insecticides, calcium and barium carbonates. So what you see in the picture, these are the industrial drum dryers, which are really huge, almost around 3 meters in diameter. Coming to the next, this is the spray dryer. This is a very sophisticated equipment. And in this, like we have been saying that drying is removing small material, small amounts of water from solid substances. But in the spray dryer, you are going to dry liquid substances. Liquids and suspensions can be dried in the spray dryer. So the principle is here that the fluid to be dried is atomized into fine droplets, which are thrown radially into a moving stream of hot gas. So here you will see that you are going to have the solvent with the material that you're going to be drying, which is going to be entering into this. Here atomization takes place, and this is the drying chamber which is connected to the cyclone. So, and this is how a spray dryer looks like. So the construction is, it consists of a large cylindrical drying chamber with a short conical bottom. As you can see, it is made up of stainless steel. It is also made up of glass in case of laboratory scale spray dryers, and the larger ones have a diameter of around 2.5 to 9 meters and the height around 25 meters. So you can see here they literally have ladders to go up. So it is a very huge equipment in the industries. An inlet for the hot air is placed in the roof of the chamber there, and here that you can see, and another inlet carrying the spray disc which is connected to the cyclone separator. So here the hot air is placed in the roof of the chamber, and another inlet carrying the spray disc atomizer is set on the roof. Spray disc atomizer is about 300 millimeters in diameter, and it rotates at a speed of around 3000 to 50,000 rpm. All of this can be adjusted. The temperature, the speed, the flow, inflow, feed flow can be adjusted. The atomizer can be adjusted to get the particular desired particle size after drying. Now, spray drying takes place in 3 steps. First is atomization of the liquid, second is drying of the droplets, and third is the recovery. So what do you mean by the first one? That is atomization of the liquid. So in this, the feed is introduced through the atomizer, either by gravity or by using a suitable pump to form fine droplets. The properties of the final product depends on the droplet form. The atomizer can be a pneumatic atomizer, it could be a pressure nozzle type, or it could be a spinning disc atomizer. The rate of the feed is adjusted in such a way that the droplets should be completely dried before reaching the walls of the drying chamber. So whatever has to happen before the particle falls from this point and reaches here, it has to come down completely dried. So depending on this, the speed of the atomizer, the size of the droplet, and the heat is going to be controlled. Then drying of the liquid droplets. So what happens in the first step is, here the surface of the liquid drop is dried immediately, which is form a tough shell, but there is going to be little amount of liquid that is going to be inside this tough shell, which has to be removed. So heat transfer from outside to inside, it takes place at a greater rate than the liquid diffusion rate, and as a result the heat inside mounts up, which will allow the liquid to evaporate. This leads to an increase in the internal pressure, which causes the droplets to swell. Then the shell thickens and the decreases, whereas the permeability for the vapor increases, and therefore if the shell is neither elastic nor permeable, it ruptures and the internal pressure is going to escape, and the entire particle is then going to be dried from within. Then centrifugal force of the atomizer drives into follow a helical path. The particles are dried during the journey, and finally they fall at the conical bottom. All these processes are completed in a few seconds. Therefore, particle size of the final product ranges from 2 to 500 millimeters. The particle size depends on the solid content of the feed, the liquid viscosity, the feed rate, and the disk speed. Then the capacity of the spray dryer is almost around 2000 kgs per hour. So you know, it shows how efficient it is. Advantages: it is a continuous process and drying completes within just 3 to 30 seconds. The labor cost is low. The product is uniform and controllable size can be obtained. Fine droplets provide large surface area for heat and mass transfer. Product shows excellent solubility. Either solution or suspension or thin paste can be dried in one step to get the final product ready for the packaging. Drying of sterile products and reconstituted products are done by spray dryers. Globules of an emulsion can be dried with the dispersed phase inside and layer of continuous phase outside. The disadvantage is that it is a very bulky and it is also expensive. Huge equipment is always easy to not very easy to operate, and the thermal efficiency is low as much heat is lost in the discharged gases. Uses: it is used compulsorily if the product is a better form than that obtained by any other dryer, the quantity to be dried is large, and the product is thermolabile, hygroscopic, or undergoes chemical decomposition. So a few products that are done by spray dryer, that is citric acid, gelatin, barium sulfate, detergents, sulfur, blood, pancreatin, hormones, serum, vitamins are all dried, and starch. These are all dried using the spray dryer. Then coming to the next, this is the fluidized bed dryer. It is also called as FBD. Hot air is passed. So this is a fluidized bed dryer. What you can see, the industrial make. Hot air is passed at high pressure through a perforated bottom of the container containing granules to be dried. The granules are lifted from the bottom and they're suspended in the stream of air. And this condition is called as the fluidized state, and therefore the name fluidized bed dryer. The hot gas surrounding every granule to completely dry them, and the materials granules are then uniformly dried. So here you will see the construction. This is the perforated bottom that is there. Here again you have air. So filtered air comes in. There are heaters. Air gets heated, goes through, passes through this perforated basket. When it passes through this perforated basket, it lifts, that is with the velocity of the gas that is coming or the air that is lifted, it lifts the particles. These particles are lifted, and as they are suspended in this hot gas, the particles are going to be dried. There are filter bags that are kept, that is the finer particles will go and stick into the filter bag. Once they are dried and it is stopped, then the filter bags are shaken, the dried material comes in, the perforated basket is deloaded, and the fresh batch can be put. This is how it works. So there are two types. This is the vertical type. You could also have a horizontal type. So the dryer is made up of a stainless steel or plastic detachable bowl, which is placed at the bottom of the dryer, which is used for charging and discharging. The bowl has perforated bottom with a wire mesh support for placing the materials to be dried. So this is the wire mesh on which the materials going to be placed for drying. Fresh air inlet, there is a pre-filter and heat exchangers are connected serially to heat the air to the required temperature, which can be regulated. The temperature of the hot air and exit air are monitored. Bag filters are placed above the drying bowl for the recovery of the fines. So the wet granules to be dried are placed onto in the detachable bowl, and it is pushed into the dryer. The fresh air is then allowed to pass through a pre-filter, which subsequently gets heated by passing through a heat exchanger. The hot air flows through the bottom of the bowl. The air velocity is gradually increased. When the velocity of the air is greater than the settling velocity, the particles remain partially suspended in the gas stream. A point of pressure is reached at which frictional drag on the particle is equal to the forces of the gravity. The granules rise in the container because of the high velocity gas and later fall back in a random boiling motion, and this condition is said to be as the fluidized state. The gas surrounds every granule to completely dry them. The air leaves the dryer by passing through bag filters. The entrained particles remain adhered to inside of the bag. Periodically, the bags are shaken to remove the entrained particles. Advantages: it requires less time to complete, that is less than around 20 to 40 minutes compared to the 24 hours of the tray dryer, because that is time consuming. Different sizes with different drying capacity from 5 to 200 kg can be done. The handling is simple, the labor cost is low, the thermal efficiency is around 2 to 6 times than the tray dryer. Mixing efficiency is also high as compared to the other dryers. Hot spots are not observed in this kind of a dryer. It is more seen in the tray dryer. Then you Hotspots are not observed. It facilitates the drying of thermolabile substances as the contact time is again short. It can be used for batch type or continuous type. And it has high output from a small floor place. The free movement of the individual particles eliminates the risk of soluble material migrating as may occur in the static bed. The disadvantages are quite negligible, but even then, many organic powders develop electrostatic charge due to drying. To avoid this, efficient earthing of the dryer is necessary. The turbulence of the fluidized state of granules may cause attrition and may lead to size reduction. So, if it is not desired, we have to consider this. And fine particles may become entrained, and it must be collected by the filter bags. Uses: it is popularly used for drying of granules in the production of tablets. It can be used in the three operations like mixing, granulation, and drying. And it is also modified for coating of granules. So you will see that it can be used for multiple purposes. Other than drying, it can also be used for mixing and also for coating. Thank you.